Okay, so starting off with multiple choice, it says a single six-sided die is rolled. So you're just rolling a die, one die, 1 through 6. Okay, find the probability of rolling an even number. With these problems, it's always good in your mind to identify what's the total number. That would be 6, right? You just write it somewhere. There's 6 possibilities. The numbers 1, 2, 3, 4, 5, 6. Now, the chance of rolling an even number. Well, how many even numbers are on a die? Well, that's going to be 2 and 4 and 6. You can write this anywhere you want, whatever. But that is a total of 3 possible out of 6. Well, I don't see 3 6 on here. Well, let's reduce it. That reduces 1/2. I don't see 1/2 on there. Oh, yes, I do. It's right here. It's 0.5. Okay? So 0.5 is the same as 1/2, which is the same thing as 3 6. In other words, you got 50-50 shot of getting an odd or an even. Okay? Let's say it was the chances of rolling a 6. Well, there's only one of those. That would be 1 out of 6. What if I said a number greater than 4? Now you have to be careful with that because greater than 4 does not include 4. So that means the numbers 5 and 6. That'd be 2 out of 6 or 1 out of 3. Twinkle, twinkle, twinkle. Okay, in a study of 700, well, we already have our number right there. That we know 700 is total. 325 carried a balance, but got to be careful when you read this one. This was a tricky one. I threw a curveball in here. What is the probability that a card owner does not carry a balance? So you have to ask yourself, am I going to use that number 325? Yes and no. 325 is the ones who carry a balance. I want to know how many don't carry a balance. So first off, I have to start by doing some subtraction. Okay? I have to subtract 325 from 700 because that's the total number. And that's going to give me 375, which are not out of 700. All right? Now, obviously up there, you do not see that fraction anywhere. Okay? But if we reduce, now you can reduce by 5, okay? But hopefully your brain goes, wait a minute, those are all multiples of quarters. I can divide by 25. Eventually I'm going to get down to 15 over 28. And the answer is A again. Okay? If I divide by 25, I will get down to 15 over 28. Number 3, if one card is drawn from a deck of 52 playing cards, what's the probability of drawing a queen? Okay? Well, remember, there's 4 suits. Hearts, diamonds, spades, and clubs. There's 4 suits. That means there's 4 queens. There's 4 jacks, 4 tens, 4 twos, 4 of each suit. So, how many queens are in a deck? 4. Out of how many? 52. Number's not up there. But 52 is an even number, so you might just start by dividing by 2, which is 2 over 26. Also still both even, and guess what? There's your answer right there. Crazy. A again. At this point you're trying to wonder, wait, it can't be A, there's 2 A's in a row. Psyching you out. Alright, so it is 1 out of 13. Another way to think about that is, a shortcut to that is, each suit has 13 cards. There's 1 queen out of each 13. So you could have gone right to that. It doesn't matter how you think about it. Number 4. First thing we need to do with these numbers is total them up. Okay? And when you total them up, you find out there's 100 blood types there. Okay? 100 blood types. And you can actually do this pretty much mentally if you think about it. You know, this is an easy number. That's 40 right there. And 6 and 4, that's 10. And then, you know, that's another 10, and 37 and 3 is 40. So you can actually do that mentally without a, if you see the short combining. But then it says, what are the odds, the chances, the probability of getting a negative blood type? Let's see what those are. There's 6 here, there's 6 here, there's 2 here, and there's 1 there. 6 and 6 is 12, plus 2 is 14, plus 1 is 15. That's 15 out of 100. That answer is not up here, but yes it is. 15 over 100 is 0.15, and I almost wrote 15. C, okay, 15%, 0.15, 15 over 100. Number 5, got a bag with 5, 4, and 3 marbles. That's 5 plus 4 is 9, plus 3 is 12. So there's a total of 12 here. Just want to make note of that somewhere. Okay? Now, it says, what's the probability of choosing 2 red marbles without replacement? You've got to remember to look for those words, with and without replacement. So let's see what that means. I pull a red marble out. Well, first off, what are my chances of getting a red marble? Well, there's 4 red marbles out of a total of 12. Now, if I want to make my life easy, so I'm going to be doing some multiplication here, go ahead and reduce this right off the bat. That's just 1/3. That's 1 out of 3 marbles. Now, I know there's not 3 marbles in the bag. There's 12, but this is the same equivalent number. Now, I take the red marble out. I don't. Without replacement means it stays out of the bag. So therefore, it's not the same bag. There's not 12 marbles anymore. There's only 11 marbles. And instead of there being 4 marbles in the bag, red, I already took 1 out, so there's only 3 left in the bag. And I can cancel the 3, that's easy math. So that gives me the answer of 1 over 11, which is not up there. Okay? I could check and see, well, let's see. 11 goes into 33 3 times. Well, that would be 3 33rds, not 5 33rds. So it doesn't work for any of these. So therefore, the answer is E, none. And last one on this page, speaking is hard. Determine whether it's valid or invalid. Well, remember, a probability is valid if it's between 0 and 1, including those numbers. 0 means no chance. 1 means certain chance. It's going to happen for sure. Okay? So, like, there's no chance of me winning an Oscar this year. Not going to happen. I wasn't in a movie. So there's no chance. There's 0 probability of that. Okay? 1 would be for sure. Okay? I am for sure going to post this video after school. 100% chance, I guarantee it. Well, we might want to make it 90 because I do agree. Okay, so 0 to 1. We got to check. Is each number between 0 and 1? Can't be negative. Okay? And it can't be bigger than 1 or an improper fraction. 0.1. Well, that is the same number as 1/10. 1 out of 10. 0.1 is 10 cents, between 0 cents and $1, so that's valid. 13 over 11, yes, it's a fraction, but it's an improper fraction. This is the same thing as 1 and 2 11ths, which right there tells you it's bigger than 1, because the numerator is bigger than the denominator, therefore it's invalid. -1, don't want any negatives, so that's not possible. So that's invalid. And 0, even though we think about it not being a number, it is a number, and that's a valid chance. Again, we win an Oscar. Okay, back page. Determine the probability of the complement of each. Okay? Well, remember, complement, we're stepping away from geometry in the sense of, we're used to thinking complement means adds up to 90 degrees. Not here. Okay? Complement means what would make 100%. 1, 1.00, 100%. So think about it this way. You go into a dollar store and you buy a 43-cent candy bar with tax. You give them $1, what's your change? That's all this question is asking. You pay 43 cents, what do you get back? So this is really going to be 1 minus 0.43. That means you're going to get back 57 cents. No, not 5.7, 57 cents, 0.57. Now, remember, this little c there means the complement. That's just the symbolic way of writing it. But it's in the instructions also. Now, 7/9. You could turn that into a decimal. The problem is it's a repeating decimal, 0.7 repeating. So we're not going to do that. But think about it, okay? If you got a 7 out of 9 on a quiz, 100% would have been 9 out of 9, right? So how many did you miss? So this is just 9 out of 9, which equals 1. That's an equal sign. 9 over 9 minus 7 over 9, which equals 2 over 9. So you can think about it as money, like this, or even 0.57 is 57%. What did you miss? You missed 43%, that kind of thing, or 43, 57. So 7 ninths and 2 ninths make a whole. 57 cents and 43 cents make a whole 1. Okay, when events are independent, and I know we learned in the notes about the dependent, there was a whole extra combination we had to multiply and subtract. We're not doing that here. All we're doing here is saying, if A is independent of B, the way you find the probability of both happening, we already did it with the card problem, or the marble problem, taking them out. They were independent. Oh, that was the dependent one. Sorry about that. All we're going to do here is just multiply them. So we're just taking these two and multiplying. 0.1, 0.7 times 0.2, which gives us 0.14. Here we have probability A and probability B. We're just going to multiply them, which gives us 0.02. Hopefully you got 0.0243. Now, this one's trickier. Not hard, it's still tricky. You got to pay attention. You're not going to multiply these two because notice this, okay, is A and B. That's the answer. So in other words, we're going to take this number and divide them backwards, obviously. So we're going to do 0.22 divided by 0.31. Because 0.31 times something is going to give us 0.22. And that something is 0.71. Same thing on number 15. We already have our answer here. We have one of the numbers. We're trying to find out what the other number is. Okay, left off here. We're going to do 0.38, because that's the answer, divided by 0.6 to find out what the other multiplication part would be. And when we do that, we get 0.63, I believe. If I'm writing, it's hard to believe. Yep, 0.6 is 73 repeating. Okay, 16. Now we're trying to determine if it's independent or not. So we got a bag of 3 reds and 9 green. So that's 12. So we just write that down as we have 12. So we might have to do some calculations. It says, what's the probability of selecting 2 red without replacement? Okay? So the key word is without again. Okay? Since we're doing without replacement, then that is not independent. That might be a goofy way of thinking about it, but just think about it. If we're taking one out and not putting it back in, the second one depends on the first one. So not independent is the same thing as saying dependent. So in our brains, we've been saying dependent. That's the same thing as not independent. Now notice it says, if it's independent, do this part. But since it's not, we're not doing anything there. Number 17. Given the standard deck of cards, right off the bat, we know that number, special number is 52. What's the probability of selecting a 5 and then a jack with replacement? Okay? So, if we take a 5 out, but then we put the 5 back in, and we shuffle the deck, it's the same deck. So when we take the second card out, The first card has no effect on that because it's back to being the same deck. So that means it's independent. Oh, sorry. I'm going to move this one up here. You just go there. Independent. Got ahead of myself. Okay? So if it's got replacement, it's independent. Now, since it's independent, we got to do some math. So, how many 5s are there in a deck? There's 4 of them out of 52. And then, how many jacks are there? Well, there's 4 of them out of 52. Now, we already talked about this. If you think about it, there's also 1 in each suit. So you could simplify both of these to 1 out of 13 and 1 out of 13. We're just going to make it a lot less work. You don't have to reduce anything. And you're going to get a probability of 1 over 169. If you don't reduce, and that's perfectly okay, you would get 16 over 2704. And I would accept either answer. It doesn't have to be reduced, unless the instructions say to put it in simplest form. It doesn't. Okay. Given a standard deck of cards, again that's 52. What's the probability of selecting an ace and then a 2 without replacement? Well, if it's without replacement, that means the first one is going to affect the second one, which is the same thing as dependent. So it's not independent. All right, number 19, last one. There were 60 students observed. Remember, who cares who has brown eyes? Okay, there are 60 students observed for their height. Right off the bat, you can go and put that number on, because that's the total. That's the total number of kids completely. So we can put that on there. Now we got a label. Remember, this box is going to stay empty. It doesn't matter whether you put boys and girls on the top or boys and girls on the side. It makes no difference. And basically, you just need to have some kind of something. So I put below average and above average. You can just write the words below and above. You can put an arrow up and an arrow down. I don't care. As long as you know what it means, that's fine. Okay? So, it says there were 17 boys below average. So we find boys below average and we put a 17 there. It says 23 girls were above average. So girls, 23, boom. Now, we can't do anything yet. We don't have enough information. That's why we find out that 10 girls were below average. So we put 10 here. Now that we have that, everything else falls like dominoes. 10 plus 17 is 27. 10 plus 23 is 33. 60 minus 33 is 27. 60 minus 27 is 33. And 33 minus 23 is 10. Bam. And no, that just was an accident. I did not mean it to be the same numbers. 27, 33 is worked out that way. Okay? Now that we have it filled out, which is what we had to pray, we can move on and use the table to analyze given information. How many boys were observed? So since it says boys, you follow that line. Boys is a row in this one. Again, if you put boys and girls on the top, you follow boys down the column. I'm going across, and I know that there were 27 boys total. What's the probability that a boy is above average? Okay, so boy, okay, above is right here. Okay, so boy above average would be 10 out of 33. Because we're going down the line. We wouldn't do 10 out of 27. Okay? The boys above average. Actually, wait a minute. Hold on. I confused myself now. If we got boys, 10 are above average. Sorry, out of total boys. I had it right the first time in my mind. I can talk myself out of it. 27. Because you've got boys, there's 10 of them that are above average out of a total of 27 boys. we're starting with boy. We're given boy, and then have to find above average. And then what's the probability of below average? Well, we just need to find the total below average, which is 27, out of the total, which is 60.